So why am I here? This is the first reason why I'm here. My YouTube channel. You have to take into account that this is a German channel, so these numbers, these figures may not look that big, but it's in German. So I do not have too many viewers from India, say, on that channel. It's about mathematics and computer science, more or less what I recorded in class, plus some additions. That's one of the most popular channels of that sort in Germany, reason number one. By the way, it's also listed on YouTube Edu, on the portal. And I have around, say, 10,000 views per day, give or take. Sometimes it's more, sometimes it's less. On the weekends, it's less. And that's the second reason. My first MOOC, Massive Open Online course, Udacity course that started several weeks ago, which, by the way, is not synchronous. So Udacity switched from the synchronous model to the asynchronous model. Now it's hop on, hop off. You can start at any time. There are no deadlines. You can take the exams when you want. Maybe that's a point for discussion later on, if that works or if that doesn't work. What I want to talk about is summarized here, 4 points. I want to talk about the content of these videos, the style of these videos, the tools that I developed and that I'm using, and the usage, the ecosystem around that. It's not just videos, as we've heard before, it's way more than that. I want to start out with style, because I guess the style that I'm doing my lectures in defines most of the other items. I do not like PowerPoint at all. So here I'm forced to be using PowerPoint. I don't like it at all. I want to present ideas in a more flexible shape. I want to integrate text and graphics. I want to develop clouds of ideas. I do not want to have the linear list of bullet points. So PowerPoint doesn't really work for me. Drawing works for me, drawing and writing from ancient times or not so ancient times. Obviously, drawing is quite a natural activity for humans. This is a classic example, Donald Knuth, 1981, explaining the inner workings of text in a video. He draws how characters are being put into boxes and boxes are put into larger boxes to form lines and paragraphs and so on. Pretty close to what I'm going to show in the next slides. That's another landmark, Wilfred Planck's lecture 2000 on HCI, human-computer interaction. Highly sophisticated diagrams done in real time. He's speaking and drawing at the same time. This is, I guess, what got everybody starting. Salman Khan, one of his first videos, 2007. You see his style has improved a little, but it's still bright lines on a dark background. 2009, I started. That's one of my first lecture videos. Here I even experimented with a webcam video inside. That's me, obviously, taken from a webcam. And that's from this year, my Udacity course. You see, I didn't change that much over the years. Now it's an actual hand, my actual hand, that's visible on top of the drawing, but no other vital changes here. So that's the style of videos that I'm doing. Using the video screen like a whiteboard. Not too much text, it's not really crowded, very visual explanations. That's what I'm aiming at. The tools that I'm using, that I have developed for that, what doesn't work is this, actually. Christian Spannagel is a professor at Heidelberg, Pädagogische Hochschule Heidelberg, who also puts up tons of videos on YouTube, recording what he does on the green board, on the blackboard, and that doesn't really work for me. First of all, the resolution, so to speak, the pixels per inch of that blackboard is way too high. It's pretty hard to read sometimes. Then you often have distracting parts in that video. What's on that lectern? Did he have a coffee before, or was it a tea? That's distracting. Tons of unused pixels. 1/3 of that image is not used. When you work on the blackboard, with the blackboard, you're looking at the blackboard away from the viewer, which is not very friendly, and which is a knockout argument for me. You need a cameraman like we have here. I do not have any personnel, I do not have any financing, I need to do it without. That's my solution since 3 years, just a regular tablet PC. I'm recording the screen of that tablet PC, I'm connecting a microphone to that, and that's it. I have to mention a tablet PC, which is a Windows notebook computer. It's not an iPad, it's not an Android tablet, it's a very old-fashioned machine, a Windows computer with a screen that can be written on. And this is how it looks for my students in the classroom. The recorded part is just the pixels with that red rectangle around. So you do not see all these interface elements in the video. I have some controls for myself. That's a small software that I've written. I have some controls for myself to add a pause when there's discussion in the classroom, or to add some markings to say I should be editing this afterwards. The vital point is not to edit at all. Once you start editing these videos, you're lost. It's going to take ages. So what I'm focusing on is to prevent any editing. The video has to be ready for uploading when the lecture is over. In case it is not ready because I said some nonsense, I have a special video editor developed for my own purposes, which allows me to do this sort of video editing in just several minutes per video. I just show some amenities. It has a controllable speed. The pitch of the speech remains the same, but you can speed up or slow down by a factor of 2. So you can listen to 20 minutes of lecture in 10 minutes if you want to, just to get ahead quickly, or if you want to really get some detail, catch some error, you go down to half the speed. That's one option. I'm too using speech recognition. That's a Windows built-in speech recognition engine that I'm using. It's pretty bad, so every second word is wrong, but you get the gist of it. You know where you are in that video, thanks to speech recognition. Some fancy computer graphics. I once was a professor of computer graphics, so I have to add that one. And the editing is pretty simple. You just click where you want an edit to be made, and that's it. No menus whatsoever. As you can see, it's very straightforward. So I guess one of the tricks for quick editing is to have the right kind of software. You cannot use such things as, say, Adobe Premiere or Apple Final Cut. Way too big. You have to have something specialized for lectures. I did some further experiments. This is one where I synthesize a hand. So this is not an actual filmed hand. It's a photograph of a hand. This is the photograph of a sleeve. And I use computer graphics, inverse kinematics, that is, to make the hand follow the stylus. So all of that is faked. It was an experiment. Another experiment is this one. Again, this virtual hand, now behind the transparent board, if you will. And I'm using the image of the webcam plus some background suppression to give the idea that I'm standing behind a transparent blackboard. This looks very fancy. Actually, in the end, I decided not to use it. The effort that it takes to set up the camera, to control the lighting, and so on, way too much. It doesn't really help in learning. This is what I learned. So you can do tons of nice effects, but in the end, you have to answer the question, does anybody learn better because of that? And I found it doesn't seem to be the case. I said, currently I'm using a tablet PC computer, an old-fashioned Windows-based tablet PC computer. This is software that I developed for an Android tablet. You can do most of that stuff on the Android tablet. That works easily. Recording and whatever, no problem today. The issue is writing. With the iPad tablets and the regular Android tablets, handwriting is really tricky. The nice thing is now that Samsung offers these newer tablets, these newer Android tablets with Wacom pens. They do work. So I guess in future I may move from a tablet PC to an actual tablet. It's way easier to handle, way easier to set up in the classroom. That may be the future. Where do I put these videos once they are ready? Of course, YouTube. This is how this talk is being named. Both the Udacity videos end up on YouTube and my own homemade, homegrown videos end up on YouTube. Nice thing is it's for free and tons of amenities again. When I do find an error, or actually when viewers find an error afterwards, I do not have to re-record. I can simply put in such a speech bubble and I'm done with it. Very handy. Of course, you have comments. You can use a notation like 2:34 in a comment to say, create a link to 2 minutes and 34 minutes. You can have playlists and whatsoever. So this comes in very handy for me, for free. The ugly thing is, YouTube, being a product of Google, has a pretty flawed search function. When you're looking for one video in that mass of 1800 videos that I have, it's pretty hard to find anything in there. So I created my own search function, which is easy because YouTube has a nice API for doing so. So it's extensible. So far for the choice of YouTube, I guess that's pretty clear to see why I'm using YouTube. And because it's HTML-based, you can program stuff around. This is a bookmarklet that I've developed. With the help of that bookmarklet, you can enter some tech-like notation as a comment, and you get the nice, fully formed mathematical equations in an extra window, if you will. So that's running on Firefox only at the moment, as a bookmarklet. Nice things that you can do when you're working with regular web services, or web-based services, I should be saying, when you're working with HTML and can do something about that HTML. So much for the tools. The content. I'm striving to really squeeze down the traditional curriculum, both in my mathematics classes, and that's also one of the hallmarks of Udacity. Find the 20% that do the 80%, this Pareto principle. Get rid of the arcane stuff that nobody uses but that confuses everybody. And try to present the whole picture. I can't do that in my mathematics classes. There I'm bound to the traditional curriculum, to the descriptions of the modules that have been accredited. No chance there. With Udacity, that's possible to do something novel. To say, okay, when I'm doing differential equations, that's what my course is about. When I'm doing differential equations, I'm not speaking about chapter 1, existence and uniqueness of solutions, and chapter 2, I'm not speaking about linear differential equations, homogeneous and inhomogeneous linear differential equations, and so on and so on. No, I'm doing that with applications. So in the first 2 units, it's about how to save Apollo 13, how to bring them back. What you learn is basics on differential equations, it's gravity, it's numerics of differential equations, and pretty complicated numerics, actually stuff that you would usually do at the end of the term, symplectic solution methods and stuff like that. That's highly practical, but in a regular curriculum is way at the end, where you tend to forget it. Or say, in Unit 3, I'm introducing the ideas of equilibria and growth processes and decay processes. And in Unit 4, it's about how to not overfish the sea, how to optimize the amount of fish being harvested, how to analyze the sensitivity of my model, stuff like that. So every of these units is built around an application. It's not built around a mathematical topic. It's built around an application. And the focus is on common sense. It's not about highly abstract derivations, formulas. It's about getting the idea of what happens, why something happens. A diagram rather than an equation. And pretty small sizes of knowledge. So it's, in particular in my mathematics class, it's really broken down into units of 10 to 20 minutes, not 90 minutes. The Udacity class is even broken down into units of 2 minutes. So that's one unit. It's the unit that's focused on partial differential equations with chemistry and physics and whatever, numerics. Each of these items is about 2 minutes and is combined with tons of quizzes. This is why I called that slide get the potatoes off the couch. Just watching lecture videos does not help anybody. You have to use it. You have to get your fingers into that material. This is why there are these tons of questions and answers. Most of them are programming quizzes. So it's not just a multiple choice quiz. You really have to develop or at least add something to a piece of software. The type of quizzes is not something where you have to prove that you memorize something. It's quizzes about inventing something new. So in the section before, I explained how to numerically compute the second derivative of a function, whatever that may be. And here the task is now to apply the same idea to the fourth derivative, which is pretty much more complex. I'm not telling the viewer how to do that. They themselves have to get the idea how to do that. So it's not simply recalling memorized facts. It's developing new facts, if you will, new rules, inventing new rules. With my mathematics classes, it's not that easy. As I said, no funding, no personnel for the mathematics classes. How do I activate students there? This is what I'm doing there. My lecture notes are actually not fully formed lecture notes. There's tons of blank spaces in my lecture notes, and I ask the students to fill in these blanks while they're watching those videos. So that's easy to produce. I do not need to set up any quizzes or so manually. I just hand out these lecture notes, or actually it's only half of a lecture note, and all important diagrams, all important derivations have to be added while watching the videos. And the students actually do that. When I walk around in the classroom, I see that they actually fill in those blanks. So this gives me an idea that they are not on Facebook at the same time as they're watching the videos. They're doing something meaningful, hopefully. In particular, I guess drawing these diagrams is very helpful, I guess. Even though there's no diagram on that one. And yeah, to think has two meanings, and I like to think of the verb to think as an action verb. It's something that is happening. And this is why I show thinking in action. So when I teach computer science, I really show debugging, I show software development. I discuss with the class, this is the problem, what should we be doing? Should we be forming these two classes? What should be the inheritance? Some algorithms, whatever data structures, what's the right way to be doing it? We try things out. Me standing in the front, entering that, of course. We try things out. We do debugging, of course. There's tons of errors that need to be found. And that's thinking in action. I try that in the computer science class by showing a software developer at work. Actually, the classroom becomes the software developer. And the same is true for the mathematics classes, where I try to pose more challenging questions. How this is being used, let me address that. So I guess there's a move from courses, regular courses, to just-in-time learning. I see this in particular in place with the mathematics classes. You also heard already about social, learning is social. And on Udacity, I see that students create long, winding, highly detailed explanations of stuff that I glanced over. So the student who wrote that really learned much. And the student who asked the question before also learned much. And this is a second view on learning social. We just recently, some days ago, started to map those students. We asked everybody to put a pin on a Google Maps map. How do you form study groups there? Could you be forming study groups? And there's other things to observe here. We do know that very many students of Udacity stem from India, but there's just one single pin here. So students from India and China tend not to appear in the forums. What could we be doing about that? How do you foster social learning there? My own use is the flipped classroom. For my local students, I ask them to watch the videos at home, which is an efficient use of their time at home. And then we'll discuss and work in class, which is an efficient use of my time with them. How to proceed. We could rethink what we are doing, or we can fill old wine in new skins. Old wine in new skins, What would that be? Lectures. I guess we need to get rid of lectures. Can we have more interactive forms? Videos can replace regular lectures very easily. Let's try to have more interactive forms. Let's try to not test memorization and not to spoon feed the students. Let's try to foster discovery and invention. And then in classical university lectures, there's this chasm between theory on the one hand, which many students don't get, and recipes, which help the students to pass the test. And there's nothing in between. Can we do the stuff in between? Can we have deep understanding instead of arcane theories and shallow recipes? And I guess often we are looking too much into polished forms. Let's invest time wisely. Let's not spend too much time on PowerPoint slides. Let's spend the time with the students. And maybe the idea of courses and programs as such is flawed these days. When we move to just-in-time learning or learning communities, maybe there is no course anymore. Maybe there is no study program anymore. I'm running out of time, I guess. Let me just do this briefly. 3 problems that I see on the way. First, log in, like on that machine. So even on your tablet computer, you see QWERTY, which does not make any sense, strictly speaking. If you would be designing a keyboard these days, you would not arrange the keys in that fashion. We are locked in. We've gotten used to that, and now we can't escape. It's the same true for universities, for how we structure courses, that we focus on recipes, or at least students focus on recipes. Can we break out of that situation, or are we locked in already? Diversity. On Udacity, in the forum, you see people like that say, oh, I've done lots of courses on the internet, I really like it, and I take any course that I find. And with my own students at home, so to speak, I'd rather have that situation on the left-hand side. They do not really know why they are in the lecture hall. With MOOCs, massive open online courses, we can easily cater for the people on the right-hand side. You are going to catch them. With them, it's easy. These are the thousands of students we have in the MOOCs. What should we be doing with 100,000 or hundreds of thousands of students in the universities? What's the right way of teaching, of learning for them? And money gets scarce. We are being told. So on the one hand, I do think that the opinion of Arthur Clarke is right. Any teacher that can be replaced by a machine should be. But then again, the administration of the university, the Secretary of Finances may have a different look on that. So they may think, okay, now we can get rid of universities as such because everything can be handled by video, which of course is wrong. What is a teacher that can be replaced? Can actually any teacher be replaced? Which functions should be replaced? Should teachers be doing something different? So this should not become a way of saving money. This should become a way of improving education. In the end, the question is, what's going to become the next item on show in the Museum of Jurassic Technology? The university, as we know it, may become Jurassic, maybe not. It really depends. At the moment, I do not know. Thank you very much.